Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science, Chapter 1 Forces, and we are on 1.7, Part 2, and we're going to be going over our questions. So right now you should have number 1 done. I'm going to skip down to 1.3. You should have number 6, 7, 8, and we're skipping number 9 and 10 and 11 for now, and you should have number 12, 13, 14, and 15 done. Do you have those done? So let's come down to 1.7, Newton's third law, and number 17. So on figure B, mark all the horizontal forces acting on the block and all the horizontal forces acting on the cart. Explain which pairs of forces are equal and why. So let's talk through this picture. So we have our cart and our block and our spring scales. So force A is moving this way, and it is the force of the spring scale on the cart. And then force B is moving this way, and it is the force of friction from the block on the cart. And then we have force D, which is this way, which is the force of the spring scale on the cart. And then finally we have force C, which is going this way, and it is the force of friction from the cart on the block. So looking at our answer, force A is the force exerted by the spring scale on the cart. It is equal and opposite to force, and then you write which force here. Don't leave your answer in there. You should answer either B, C, or D, which is the force exerted by the block on the, and then you would put in the object right here for your answer. We know that these two forces are equal and opposite because the cart is not moving. Then up here, force C is the force of friction exerted by the what on the what. Force D is the force exerted by the what on the what. And so you would put your answers right here. And we know C and D are equal and opposite because, well, we know if forces are unbalanced, if the forces on the block would be unbalanced, it would be moving. But if the forces are balanced, or if two forces are equal and opposite, then we know it would not be moving. So you want to put your answer right there. And then forces A and blank are equal and opposite because the cart and the block aren't moving. So over here, we already talked about A and B being opposite. So you'll want to see what other force is opposite to A. And then force C and blank are equal and opposite because the block and the cart aren't moving. Well, we already talked about C and D being opposite. So what other force is opposite to C? And we know that these forces have to be equal and opposite because the block isn't moving in relation to the cart or the spring scale, and the cart isn't moving in relation to the spring scale or the block. Okay, next, consider two magnets mounted on two carts with low friction wheels as shown in figure C. The carts are at rest. The forces exerted by the two spring scales are equal and opposite. Explain why the forces that the magnets exert on each other are equal and opposite. Okay, so we can see that there is quite clearly a larger magnet here than there is here. But the question, number 17, tells us that the spring scales are pulling with equal amounts, and it says that the carts are at rest. So if there is a force A and a force D that are opposite and equal, then we know that forces B and C also have to be opposite and equal. So just like Newton's law says, for every force, there's an equal and opposite force. So even though this magnet is larger, the forces of attraction between those two carts are going to be equal and opposite. So looking down here at our answer, the forces that the magnets exert on each other are, well, are they equal or are they unequal? We know that they're equal because the carts, well, are the carts moving or are the carts at rest? Also, the forces shown on both spring scales are, and then here with your answer, you'll want to put equal or unequal. And since the forces on the spring scale are equal and opposite, then the forces between the two magnets must also be equal or unequal and opposite or in the same direction. So please fill out those, and then we will be done with our 1.6 and 1.7 questions. All right, thank you. Bye.